sky. Just points of light scattered across the sky in what looks like total randomness. No labels, no lines connecting them, no guide explaining what any of it means. And somewhere around 30,000 years ago, a human being looked up at that chaos and did something that, as far as we know, no other species on this planet has ever done. They noticed that a particular point of light showed up in the same place, at the same time, night after night. They remembered it, they went back to check, and then they scratched a mark into a bone to keep track. That is the beginning of astronomy. Not a telescope, not a laboratory, a scratch on a bone. And the story of how that scratch became the Hubble Space Telescope, the theory of gravity, and a working map of the observable universe is, by a wide margin, the longest continuous intellectual project the human race has ever undertaken. So how did we get from scratching bones to mapping the cosmos? The answer starts before history, and I mean that literally because history requires writing, and astronomy is far older than writing. Everything we are about to cover for the next several minutes happened in what archaeologists call prehistory, the period before any human being anywhere on Earth could record a single word. The only reason we know prehistoric people were watching the sky at all is that some of them left marks, small, deliberate, precise marks on things that survived. In 1950, a Belgian geologist named Jean de Heinzelin was excavating near the shores of Lake Edward in the Congo when he pulled a small object from a layer of volcanic ash. It was the fibula of a baboon, roughly the size of a pencil, with a chunk of quartz jammed into one end. Carved into its surface were 168 notches, grouped into 3 distinct columns, in a pattern that immediately looked intentional but did not correspond to anything simple like counting livestock or keeping score. The bone sat in the Royal Belgian Institute of Natural Sciences in Brussels for 2 decades before anyone proposed an explanation that made sense. In 1972, American researcher Alexander Marshak put those notches under a microscope and argued, in his book The Roots of Civilization, that the groupings tracked the phases of the moon over roughly 6 months. Not random, not decorative. A lunar record. A calendar. The Ishengo bone is roughly 20,000 years old. If Marshak was right, someone was doing astronomy 20,000 years ago with a dead baboon and a sharp rock. Now, his interpretation is debated. Some scholars think the marks are mathematical sequences, possibly prime numbers. Claudia Zaslavsky proposed they might track menstrual cycles. Others think they are tally marks for something we will never identify. But here is what nobody disputes. The marks are intentional, they are grouped, they follow a pattern. Somebody was counting something that happened in visible, regular cycles. And the most obvious thing in the natural world that does that is the moon. That is astronomy's first fingerprint, carved into bone during the Ice Age. And the Ishengo bone is not even the oldest candidate. Marshak also analyzed a carved bone from Abri Blanchard, a rock shelter in the Dordogne region of France. It is roughly 30,000 years old. 69 pitted marks wind across its surface in a serpentine pattern, and Marshak argued that the marks, made with different tools over time, track the waxing and waning of the moon across about 2 lunar months. If that interpretation holds, then humans were systematically recording lunar phases during the Upper Paleolithic. 30,000 years ago, for context, writing would not be invented for another 25,000 years. Think about what that means. The sky was the first thing humans studied. Not plants, not animals, not the soil under their feet. The sky, and the reason is not poetic. It is brutally practical. If you are a hunter-gatherer and you need to know when the river will flood, when the herds will migrate, when the days will start getting shorter, when the coldest months are coming, you need a clock. And the only clock available to a person with no technology whatsoever is the sky. The moon changes shape on a cycle of roughly 29.5 days. The sun rises in a different spot on the horizon depending on the season. Certain stars appear at certain times of year and disappear at others. The sky is not random. It is a machine, a giant, slow, spectacularly reliable machine, and the humans who figured that out first survived, the ones who did not, did not. Astronomy was not a hobby. It was survival infrastructure. And the oldest continuous astronomical tradition on Earth belongs to the Aboriginal Australians, people who have been watching the sky for at least 50,000 years. Dwayne Hamaker, an astrophysicist and author of The First Astronomers, has spent years working with Indigenous elders to document this knowledge. And what he has found is extraordinary. Aboriginal Australians do not just have constellations. They have dark constellations, shapes formed not by connecting bright stars, but by the dark dust lanes of the Milky Way itself. The most famous is the Emu in the sky. Its head is the Coalsack Nebula, a dark patch beside the Southern Cross. Its neck stretches through Alpha and Beta Centauri. Its body extends along the dark clouds of the Milky Way. And the position of this dark emu in the sky tells you, with real precision, what is happening on the ground. When the emu rises after sunset in April and May, it signals the start of emu breeding season. When it sits high in the sky by June and July, the males are sitting on eggs, and that is when you collect them. When it tips perpendicular to the horizon in August and September, the chicks are hatching. The sky is telling you when to eat. That is not mythology. That is applied science. And it is older than every pyramid, every city, and every written word on this planet. Now, here is where the evidence gets monumental. Literally. At the Lascaux cave in France, painted roughly 17,000 years ago, German researcher Michael Rappengluck proposed that a cluster of dots above the shoulder of a large bull in the Hall of the Bulls represents the Pleiades star cluster. He also suggested that figures in another scene correspond to the Summer Triangle, the stars Deneb, Altair, and Vega. That interpretation is heavily debated. Many archaeologists argue it selectively picks dots from complex cave art, but even if Rappengluck is wrong about the specifics, the idea that Ice Age people were thinking about the night sky while painting underground is not unreasonable. They were clearly watching the sky. The question is whether they were already mapping it. In Scotland, a site called Warrenfield was spotted from the air and excavated starting in 2004. A team led by Vince Gaffney at the University of Birmingham analyzed a series of 12 pits arranged in an arc that aligned with the phases of the moon and the midwinter sunrise. It is roughly 10,000 years old and is considered the oldest known lunar calendar. Not scratches on a bone anymore. Someone dug 12 holes in a specific pattern to synchronize the lunar calendar with the solar year. 10,000 years before the phone in your pocket. In the western desert of Egypt, at a site called Nabta Playa, an expedition led by American anthropologist Fred Wendorf in 1973 discovered a stone circle. Working with archaeoastronomer J. McKim Malville, Wendorf determined that upright slabs in the circle aligned with the summer solstice sunrise. The site is roughly 7,000 years old, predating Stonehenge by at least 2,000 years. This was the Sahara before it was a desert, when it was green savanna populated by cattle herders who needed to know when the monsoon rains were coming. The summer solstice told them. They built a stone observatory in the middle of the grasslands because their survival depended on knowing exactly when the sky said it was time to move. And then there is Stonehenge. In 1963, American astronomer Gerald Hawkins used an early IBM computer to analyze the positions of 165 points at the site and demonstrated significant alignments with the summer solstice sunrise and winter solstice sunset. He published his results in Nature and followed up with a famous book in 1966, Stonehenge Decoded. The solstice alignments are now widely accepted by archaeologists. Stonehenge is roughly 5,000 years old. And here's the thing that ties every one of these sites together, from a baboon bone in the Congo to a 25-ton stone dragged across Salisbury Plain. The underlying project is the same: track the sky, predict the seasons, stay alive. Now, everything I have just described is prehistory. No writing, no written records, no named astronomers. Every piece of evidence is a scratch, a bone, a pit in the ground, or a stone dragged into position. We are reading their work backwards, through artifacts, guessing at intentions. That is about to change. Around 3200 BC, in Mesopotamia, humans invented writing. And one of the very first things they wrote down was what they saw in the sky. This is where prehistory ends and history begins. And the difference is staggering, because suddenly we are not guessing. We are reading. The Venus tablet of Amisaduqa contains observations recorded during the reign of King Amisaduqa of Babylon, roughly 1646 to 1626 BC. It tracks the rising and setting of Venus over a period of 21 years. That is the oldest known record of systematic planetary observation. Someone sat outside, night after night, for more than 2 decades, watched a single bright point of light, and wrote down what it did. Not once, not for a season, for 21 years, and then someone else picked up where they left off. That is not casual stargazing. That is a research program. And the fact that it happened this early in the 2nd millennium BC means that Babylon was already treating the sky the way a modern research institution treats a dataset. Watch, record. Compare, repeat. Babylonian astronomy only got more sophisticated from there. The Enuma, Anu, and Lil, compiled between roughly 1600 and 150 BC, is a series of nearly 70 clay tablets containing thousands of celestial omens. The Mulopin tablets, dating to roughly 1000 to 686 BC, cataloged stars, constellations, and their heliacal risings. To modern eyes, the omen texts look like superstition. If Mars appears here, the king faces war. If the moon is eclipsed there, the harvest fails. But here's the part most people miss. To make those predictions, the Babylonians had to observe, systematically, for centuries. They had to record what the sky actually did, compare it to what they had predicted, and adjust. The astrology was wrong, the observational method was right. The method was science. And it worked well enough that Babylonian astronomers eventually figured out the Saros cycle, a period of 223 synodic months, roughly 18 years, 11 days, and 8 hours, after which eclipses repeat in nearly the same sequence. They could tell you in advance the date of a lunar eclipse without a telescope, without a calculator, with clay tablets and arithmetic. By around 400 BC, the Babylonians